Hello and welcome. I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. Today we're going to be talking about a very useful package, and that is MatPlotLib's PyPlot. PyPlot is a useful tool for visualizing your data, putting it in multiple different graphs and charts. So without further ado, let's get started. Alright, so swapping over, you can see I am in a brand new Jupyter notebook. First thing we need to do is go ahead and download PyPlot. So what you can do is, if you are in Jupyter Notebook, again, you can download these right through the lines right here using the exclamation mark. If you're not, then you have to go to command line. But MatPlotLib is the provider of PyPlot, so you can go ahead and do a conda install MatPlotLib if you're using Anaconda. If you're not, you can do the same thing but pip install, and it's MatPlotLib. I'm not going to run these, but once you download them, we can move on, and you can go ahead and just import it. So import matplotlib.pyplot, and typically I do as plt, just shorthand makes it go easier. I'm also going to go ahead and import numpy and as np, and I will also import pandas just to make data processing a little easier. If you haven't tuned in to my other tutorials where I ran these or did tutorials on NumPy and Pandas, I'd suggest checking those out. I won't go too far into using them in this, but they're just good tools to know. So you can check those out. Those will be in the same series as this video. Alright, so very first thing I'll do is just show you a simple plot. So plt dot plot. And we're going to go ahead and just make up some numbers here. So those would be the x coordinates. We'll make up some other y coordinates, something like that. And then what you need to do in order to show the plot is plt.show. Actually, if you're using Jupyter Notebook, this will automatically run for you if you don't use plt.show, but it's definitely a good idea to get used to using this, because you'll start overriding your plots if you don't do that in between your plots. And we'll go ahead and run this out, and you can obviously see it plotted the x coordinates by the y coordinates. And now this is a pretty plain chart, so there's a lot of stuff that we can do to it. First off, there's no axis labels, and there's no title for the chart, so that's things we can work in. Now you want to make sure that all of this is before the plt.show, because once you do plt.show, it will get rid of your chart and you'll have to start all over. So if you do plt.title, this is where you can put whatever title that you want. I'll call this values per time. Other things are, if you want to do the x label, you can do plt.x label. And we are going to call that time. And you can do the same thing with plt.y label. And we're going to call those values. So now if I run this, you can see the chart is getting a little more improved. It's got a title, it's got some y-axis labels and x-axis labels. Other things, I only had 4 values I had to put in, 1, 2, 3, and 4 for the x-axis. As you can see, it divided it up into a little bit more. If you want to reduce those, you can actually do plt.xticks. Same thing with y, but I'll do x for now. And I'll say I only want x ticks at 1, 2, 3, and 4. So it's only going to print those values on the x-axis. Again, if I run it, you can see I'm down to 4 values. Now, sometimes you don't even want the actual values, and maybe you're graphing some title or some feature, and it doesn't necessarily have a number, so you want to change those numbers and map them to some text. You can do that by putting a comma right after this xticks, and then you can say what you want the text to be in another array. So I'll just make these the actual text of the values. So as you can see, I'm mapping the values 1, 2, 3, 4 to their text in this. And I can go ahead and graph that again. And you can see you replace those numbers with the text. Now, when you're graphing a lot of these, or if you have really long words, sometimes they're going to run into each other and they're going to overlap. So you may want to rotate the values so they kind of get out of the way. You can do that again by going to this xticks, and you can say rotation equals whatever degrees. So if I want to rotate it 45 degrees, I can put 45 in here. and go ahead, and you can see that they're now rotated at 45 degrees, or I could go up and put 90 degrees if I wanted to. But that's just a very basic line graph. We can move on to see some of the other cool things you can do with it. Let me just create some fake data. Again, I'm going to use NumPy to do this. If you haven't checked out that tutorial, maybe a good idea to go check that out, or you could just copy what I'm doing here. So Linspace is a way of just creating a range of numbers that are evenly spaced apart by however many that you want it to be. So I'm going to say give me numbers from 0 to 10, and I want 21 numbers in between there. And then for y, I am going to do same thing. So Linspace, I'm going to say give me numbers from 0 to 2, but I also want 21. So now I can go ahead and plt.plot, plot, and I'm going to say x and y. We go ahead and plot that. You can see it's a straight line. Now, sometimes you'll have multiple lines that you want to graph, and that's one thing you can definitely do with this, or sometimes you just want to change the style of the line. So I could say this first plot, and again I didn't put Plt.Show. It's probably a good idea to put that in, but you don't necessarily need it if you only have one graph that you're trying to do at a time. But going back up to the top, maybe I want to change the style of this line. So I could say add another comma, and I could say I want a blue, so put B for blue, and I want a dashed line, so I can put the double dash symbol. And now when I plot this, it changes the style of the line and the color of the line to whatever you put in there. Also, if I have multiple things I'm trying to plot, so I can, again, add another comma, add another set of x values. In this case, I'll reuse the same x values, and then I'll put new y values in. So this time I'll say y times 2. So it's taking all those y values and multiplying by 2. And if I want to change the style of that line, I could say maybe I want these to plot, so every point is a red, so R for red, and then S for square. Now when I plot this, as you can see, both of those lines are in there, and they are styled uniquely to what I gave it. Now, I mentioned before that it's a good idea to use Plt.Show, and I'll show you why. Right now, actually, if I do another Plt.plot, and I say this next one I want to be x by y squared, and I want to make these yellow, so y for yellow, and then I will see what I want to do here. I'll do the caret. So these will be yellow triangles, and when I plot this, it's not going to make a new plot right here in this next line. It's just going to add that plot to the one that's already existing. So if I go ahead and plot that, you can see it added that second plot to the original 2. And one more thing you can do, maybe I want to make this this line a little bit bigger. So I can go up to that first plot that I made, and I could say, and I could change the line width. So I could say line width equals 5. So this is going to change the line width for both the blue line and the red line. And plot that. And you can see it just made those a little bit bigger. Okay. Now, line graphs are obviously not the only thing you can do with this. So I'm going to go ahead and make some more data again. This time I'll do it from, I'll just get 6 points from 0 to 5. And for the y, I will say np, I'll just get some random values. So np.random.randint. That'll give me some random integers, and I will say I want random integers from 1 to 10, and I want 6 of them to match that y. Now you can create figures within PyPlot. Figures are, maybe you have a collection of charts that you're trying to plot, or you're just trying to change the size of the figure that's about to be printed out. So you can say plt.figure, and you can change the fig size. So maybe I want the figure size to be, let's just make it a little bit bigger. So I'll say 15 by 7. And 15 is the width and 7 is the height. And so when I print this out, it should be larger than the one I have up top here. And other unique things are, maybe I have multiple graphs that I'm trying to plot. If I went ahead and if I scroll back up to the top here, actually let me just show you this really quick. If I do Plt.Show and I split these two up, as you can see, it prints two separate charts, and they're one under another. So when you're printing, I don't know, 10 charts, they're all going to be lined up on top of each other. Sometimes you want to display those in a better way, so they're kind of in a grid format and it's easier to see. So that's what I'll show you here. You can do that by using plt.subplot. And subplot is looking for how many charts you are trying to make in one figure and what current chart that you're on. So let's say I want 2 rows by 3 columns, and I am giving it right now the very first chart. So that's what that 2, 3, 1 maps to, is the rows, column, and the current chart I'm at. So if I do, let me change up the style. So I will show you how to do a bar chart. So plt.bar, and I'm going to do feed to X and Y, obviously. And I'm going to change the title just so we can distinguish between the two. It shouldn't be very hard, but if I do a bar chart here, or call it a bar chart, and I'm just going to keep repeating this. So I'm going to copy this subplot line here. And for this new subplot, I'm obviously on the second chart, so I'm going to change that last value to a 2. But keeping the 2 rows and 3 columns the same, because that's what the figure is looking for. So I'm going to, let's just do the line chart again. So plt.plot X and Y, and then obviously change the title. To line. Other things you can do, first let me get that subplot in here. So we are now on 2, 3, 3, and you could do a scatter plot. So plt.scatter of X and Y, and change that title. I think I still have it copied. Yep, so I'm on the 4th subplot now. And now see, it doesn't change. You don't have to increment the row that you're on. If you do 4, it's going to automatically put that in the second row, since I only have 3 columns here. So you don't have to worry about that. Other things you could do plt.py. Pi, and I'm just going to pass it in the Y values. Let's see, and the last one I'll show you, let's see if I just copy this down. I'm on 235 now. Plt.hist for a histogram, and I'm going to pass it the Y values, and I'm going to say how many bins that I want. So let's just say I want 3 bins, and you can map those to however many you need. And I'll do plt.title again. And for now that'll be fine. So I'm only going to print 5 of the charts. And now if I want to show the figure, again, it's plt.show. Go ahead and run that. And you can see it gave me all 5 charts, all the different styles. Again, like the ones up top, you can change the colors, you can change the size of the points, all different sorts of things. Actually, I'll show you how to change the size right now if I add a new line. And I'm going to go ahead and again make some random values. So let's get some random integers again. And I'm going to say, just give me 50 random integers for X. I'm going to copy that. I'm going to do the same thing for Y. So I'm looking at 50 random, sorry, let's not do random integers. Let's do values from 0 to 1. So I'm looking at 50 random values in between 0 and 1. And I can add other variables like the size. And the size is looking for integers, so again, I can just make those random values for now, and I'll use random this time. And I'll say I want random sizes from 1 to 100, and I want to match those original numbers, right? So I need 50 points. And then other things are colors. You can map those using integers. So np.random.randint, and I'm going to say I want 10 unique colors, so 1 to 10, and 50 points. So if I go ahead and I do a plt.scatter, so a scatter plot, I'm going to obviously pass it the X values, the Y values, but now I'm going to pass some other variables. So S for size, so S equals the size variable we just made, and C equals the color variable we just made. And then we'll do a Plt.show. All right, so scrolling down, you can see now we have some unique colors, unique sizes, and those are all mapped to each individual X, Y value and their associated size and color values. Okay. So if we move down, now you can also, you don't have to make individual lists for each of these or individual arrays for each of these. Actually, if you have a data frame that you're importing, so actually I will go ahead and use pandas to create my own data frame right now. And again, if you haven't seen the tutorial, go ahead and check that one out. It's in the same playlist as this one. But I'm just going to combine all of that data into a data frame to show you that you can plot it straight from that. So, and I'm going to link my columns. We'll just call these what they are. So X, Y, S, and C. Again, these are just random names that I'm making up right now. And if I go ahead and I display that data, you can see it's just putting it into a data frame for me. But if I go ahead and I do another plt.scatter, so make another scatter plot, I can actually just say I want the X column, I want the Y column, I want the S column, and I want the C column. And it needs to know which data frame I'm trying to do. So I could say data equals that data variable that I just created, right? So it's passing in that data frame and it's saying, take these column names and use those as the X, Y, size, and color columns. I'll do a plt.show. And as you can see, it's the same exact plot as the one above because we're using the same exact data. But we're just feeding it through a pandas data frame rather than individual arrays. So it's very useful when you're ingesting like CSV files or something along the lines of that. Other useful things you could do is maybe you need to throw some text on your graph or point to some specific points. So we can do np.arrange. This is just going to give me the integer values from 0 to 10. Y, we can do a just some random integers, I guess. We do a rand int, and I'm gonna say random values 0 to 10 spaced 10 apart, or sorry, 10 random values from 0 to 10. And I will do a plt.plot, and I'll just throw my plt.show in here just to make sure I don't forget it. And for now, actually, I'll just print it out. So you can see it's mapping X and Y values to the random integers that we were assigning it. Now, if I wanted to throw some text in here, I can actually just do plt.text and give it the location. So the location is obviously going to map it to the X and Y coordinates. So if I say X equals 7, Y equals 1, and then you have to feed it whatever text that you're trying to give it. So I could just say, this is text. And I will go ahead and plot that to show you. That is down here at coordinates 7. It starts at 7, 1. So it's not the center of the text that you're trying to edit in, but the left-hand side. Now, if you want to point to a specific data point that you have, let's say I'm going to point to whatever the local max is. So first, let me find the local max by creating another variable. We're going to call this lmax, just for local max. And I'm going to use NumPy to figure out where that max value is. So np.where, I want to know where the y is equal to the max value, so y.max. And it's going to spit out an array, so I want the very first one. And I sometimes it's going to spit out multiple max values, so I want to make sure it's just giving me the very first local max if there are multiples. So using that, I can actually do a plt.annotate, and it's looking for the text that I want to use, so I'm going to call this local max. And now it's looking for the x and y values. So I can do xy equals, and then the parentheses is looking for coordinates now. So I want to know, so this Lmax up here is the index of where the first max value is. So if I pass it into x, so I want to say x at the max value, it's going to pull whatever that x coordinate was. And then again, same thing for the y value. So I'll pass that in. And now it wants to know what the x and y values are going to be for this text. So this is the data point I'm trying to point to, and it wants to know how far away to put the text. So I'm just going to say xy text, so x and y coordinates for the text equals, and we're going to kind of do the same thing. So I'm going to say take that max value, and for the x, I'm going to add 2 to it, so it's going to shift it to the right a little bit. And same thing for the y, I'm going to do pass in Lmax, but I'm going to, let's say, subtract 2. So it's going to be to the right of it, and it's going to be down by 2. Okay, and the next thing you can do, let me just put this on a new line here, is you can not only put text by the point, but you can also add an arrow to actually point to it. So I could say arrow properties, so arrow prop equals, and now it's looking for a dictionary because you can find multiple different values for the arrow. And for now, I'll just change the face color. And I'm going to say change the face color to be red. So I'll just go over what this whole line is doing. Plt.annotate is going to put the label local max on the graph for whatever data point that I'm feeding it. In this case, it's looking and finding wherever the first max value is. And then it's going to put the text wherever the coordinates are that I passed it, and it's going to put an arrow in between the text pointing to that data point. So I will go ahead and run this, and it looks like I have an error. Sorry, it is not arrow prop, it is arrow props, properties, plural. There we go. And you can see it found the max value right here with a red arrow pointing to it because I changed the face color to red, and the label local max. And obviously this one went off the chart, so it automatically resized the chart to make it fit. The last thing I'll show you guys is not only charts, but you can also do the same thing with images. So sometimes you'll have an array of numbers that correlate to the pixels within an image. So if I just make a random image right now, I'll do np.random, and I'll do randint, because I am trying to map values from 0 to 255, and I want the size to be 100 pixels by 100 pixels, and then I obviously have 3 channels for red, blue, and green. And I will go down, and I will do plt.figure, because I want to just change the size of my chart to be able to see this. And I'm going to say fixed size is equal to, we'll just make it 10 by 10, so I'll make it a square since I have a 100 by 100 square that I just made, or array that I just made. And I will do plt.imShow now. So image show instead of just plt.show. And what this is going to do, I'm sorry, it's looking for a value. So I'm going to pass the x value into imShow. And this is going to, if I go ahead and hit that, it is going to give me an image. And since I just passed it random pixel values, obviously it's just a whole bunch of noise. One thing, you could see that it is still plotting the axes on here when you do an image. So if you want to get rid of those, just to clean it up a little bit, you can do plt.axis, and you can pass it off. And this is just going to turn those axes off so that you just get the image. So very useful, especially when you are importing image arrays and you want to just get a visual on what you are what you're looking at, what your data looks like. And for now, that's a fairly good overview of PyPlot. There's obviously more things you can do with it. I did a lot with lines here, but you can also customize bar charts, pie charts, sorry. And there's a whole bunch of stuff you can do. And this is kind of just a general overview. And as I start going into more data processing and data visualization for some of my tutorials, I'll probably use some things that I didn't cover here. So definitely stay tuned for that. Again, if you haven't seen the NumPy or Pandas tutorial, definitely check that out. It's in the same series as this one. I go pretty in depth on those, but keep it still at a beginner level. So thanks guys, and I'll see you in the next video.